Hi guys, this video is on sp hybridization. Hope all these videos on hybridization helped you understanding hybridization. Alright, let's see what I've got to say in this video. This is what we are going to study now for sp hybridization. Let's understand sp hybridization with example of ethyne or acetylene. The structural formula of ethyne or acetylene is CH, CH, triple bond in between CC. Alright, so it has got triple bond now. So in case of sp3 hybridization, we saw that all were single bond. In case of sp2 hybridization, we saw that there was one double bond, and in case of sp hybridization we are finding that there is one triple bond. All right, let's get into it. Now C1 C2 won't be explaining, as I explained it earlier. Now these are the ground state configuration. This also I don't think there's any need of explaining, as I have explained in my other two videos of sp3 and sp2 hybridization. What we saw is just one electron from here jumps to this empty pz orbital. So that's what has happened. Again, here also we need C1 and C2, as we saw in case of sp2 hybridization. All right, so same process of mixing, recasting and remolding occurs. Here lies the difference. Now here what happens is we are using just s and p orbital for hybridization. So it is just two orbitals of C1 and two orbitals of C2. So these two orbitals on hybridization, that is mixing, recasting and remolding, we end up with two equivalent sp orbitals. This is for carbon 1. Similarly, we would also have for carbon 2. All right. And the bond angle, obviously it's linear, so bond angle would be 180 degree. Since it is linear, the bond angle would be 180 degree. So this is what we end up with. But oh, I forgot about py and pz orbital. Now in this case, we find that py and pz orbital are untouched, as we found pz was untouched in case of sp2 hybridized state. So in case of sp, it is py and pz orbital which are untouched. So what? So this. So what happens is, so we have sp hybridized orbital of carbon 1. We have sp hybridized orbital of carbon 2. We have py which is in red, py which is in red, untouched orbital, and pz untouched orbital. So obviously, what can you guess? Py and py would overlap laterally. Even pz and pz would overlap laterally. So we get two pi bonds over here owing to py overlap and pz overlap. Owing to py overlap and pz overlap, we end up with two pi bonds. All right, and there's a frontal overlap between sp of carbon 1, sp of carbon 2, frontal overlap. So we end up with one sigma bond. Then again, here also we have s and sp, frontal overlap, sigma bond. Again here, frontal overlap of sigma bond. I am sure now you would be able to categorize this. So this was sigma bond. Let's take this one at the center as sigma bond, and these two were pi bond. And what are the type? What are the types? The types are sps, sps, two sigma bonds, and here it is sp, sp, sigma bond, and we can call this as py overlap pi bond, pz overlap pi bond. So see, I didn't have to draw the structure. Now you yourself know now what are the types of bond, sigma or pi. Yes guys, check it out now. What we concluded, was it okay? Yes, it was all okay. So you can just tally this with this and just pick up pi, sigma, red, py, pi, in pencil, pz, overlap, pi, then sp, overlap, in pencil, sigma, frontal overlap, lateral overlap, so pi, frontal overlap, so sigma, frontal overlap, so sigma. That's what it is. So net result is what? We have 1, 2, 3 sigma and 2 pi bonds. Alright, altogether that's the accountability of 5 bonds. So this is for you all to check. So we have 3 sigma bond, 1 sp, carbon, sp, carbon, sigma bond, 2 bonds which are sps of ch, and then we have 2 pi bonds which is 1 py between carbon and 1 pz between carbon. So that's what is all about sp hybridization. So how many bonds do we see? 1, 2, 3, 4 and 5 bonds. Alright, out of this 5 bonds, these 2 are sigma bond. They are SPS, sigma bond. Whereas this bond which we see is again yet another sigma bond, but sp in between 2 carbons, right? And these 2 bonds that you see, one which is here and one which is there, they are pi bond, and these pi bonds are going to py overlap, and the behind one is with pz overlap. Now since it's lateral overlap, so this is pi bond, this is pi bond, whereas this is sigma bond, it's a frontal overlap. Even here we have frontal overlap. So sigma, pi. So this was the video which was on hybridization. So I completed sp3, sp2 and sp hybridization. Alright, so hope it helped you all in understanding hybridization. I would be making more videos on academic field. Hope it supports you in your academics. Alright, let's see what's coming up next. Alright, till then, see you.